All right, so this video is going to help us fill out our learning card on sample space. Now, sample space is the list of all possible outcomes. That's what a sample space is. So there's a number of different ways that you can create your sample space. And I would recommend creating your sample space so that it makes it a little bit easier to determine, makes it a little bit easier to find your specific probabilities. So one way that you could do this is you could just make a random list. So let's say we were rolling 2 dice. I'm going to focus on that, and we were looking at the sum of those 2 dice. Well, we could just start making a random list. You could roll a 1 and a 1, a 5 and a 5, or a 2 and a 4, and so on and so forth. But this is probably not the best method to use. There's a number of different outcomes that we have, and we might miss one if we don't have some kind of systematic listing. And so that's the second one. I would recommend, if you can, use a systematic listing. So this would be a sum of 1, 1, 1, 2, 1, 3, 1, 4, and 1, 5, and 1, 6. I don't have room for all of it. Or we could go, and then we have 2, 1, 2, 2, 2, 3, 2, 4, 3, 1, 3, 2, 3, 4, 3, 4, and so on and so forth. So this is a pretty good method for creating your sample space as well. Now down here I have a two-way table. If I have 2 events, and in this case I do have 2 events, rolling die number 1 and rolling die number 2, and I'm looking at their sums, I can create a two-way table like we have right here, and that's another way to create a sample space. Well, let's move to a different example. Let's say we were rolling a die and we were spinning a spinner that had colors listed on it. Well, in that case, since we have 2 events that are different events, we could use a tree diagram like we have here. So for the first branches of the tree, we have our spinner. We would spin a blue, a green, a red, or a yellow. And then for the die, we could roll a 1, 2, 3, 4, 5, or 6. So this is a list of all the different outcomes. Blue 1, blue 2, blue 3, blue 4, green 6, green 5, green 4, green 3, and so on and so forth. This right here is a list of all the different outcomes that we could have for rolling a die and spinning this spinner. And that is a sample space. So this is our sample space right here. Now, one thing I want to point out is that for the tree diagram, I would say a tree diagram is a good way for what are all the combinations of. A systematic listing is a good way for what are all the combinations of. And a two-way table could also be a good way to find all the different combinations of something happening. But what if we had a different type of question? What if we had a question that said, how many combinations are there? So if we didn't necessarily need to know what all the combinations were, and we were just looking at how many combinations there were, then we can use something called the multiplication counting principle. So if I go back to rolling a die and spinning a spinner, if I didn't want to know the entire sample space and see all the different outcomes, like what are the combinations, and I just wanted to know how many combinations there are, the multiplication counting principle tells me that I can take the number of outcomes for the first event and multiply that by the number of outcomes for the second event. So in this case, there are 4 outcomes for the spinner, blue, green, red, and yellow, and there are 6 outcomes for rolling a die, 1, 2, 3, 4, 5, or 6. If I multiply those together, I get 24. And that tells me that there are 24 different outcomes. So 24 different combinations that I have here. So hopefully this gives you a little bit better idea of what a sample space is and some strategies that you can use to create your sample space, and then also how to use the multiplication counting principle. I hope you have fun in your stats class.